Welcome back to The Explainer. This is brought to you by Forge College. Now, in our last lesson, we covered Metaplex NFTs, metadata, and mapping from ERC-721. Today, for comparing token models and next steps, I want you to think of me as your lead architect. We're putting on our hard hats, grabbing those technical pens, and drafting the absolute concrete blueprints for transitioning your token projects from Ethereum to Solana. We are moving from the EVM to the SVM. And before we pour any digital concrete, we've got to make sure our foundations are rock solid. Let's get into it. Okay, let's dive into this. Here's our architectural drafting plan for today. First, we're looking at objects versus services. Second, life cycles and metadata. Third, the decision workflow. And finally, finalizing our blueprints. All right, section 1, objects versus services, and the big mental model shift. To build successfully on Solana, you actually have to do something, well, a little painful. You literally have to completely unlearn the Ethereum way of viewing smart contracts. It's a total mental model shift. On the EVM, an ERC-20 or ERC-721 token contract is kind of like a self-contained object. The logic, the rules, the ownership data, the storage, it's all bundled together in one deployed instance. If you want to change it, you're usually looking at a messy proxy pattern or a completely new deployment. Solana, on the other hand, uses programs as services. The program itself, like the SPL token program, is a completely stateless, shared toolkit. Your mints, your associated token accounts, and your metadata are separate state accounts that just interact with this shared service. So think of it as a microservices architecture compared to Ethereum's object-oriented one. Moving on to Section 2, Life Cycles and Metadata, Mapping the Mechanics. Now that we understand the high-level philosophy, let's look at how specific mechanics actually translate. On the EVM, your logic lives right there at the token address. On Solana, it's a shared program binary. For ownership, Ethereum just uses a contract mapping, literally a list inside the contract saying, wallet X owns 5 tokens. But Solana uses completely separate associated token accounts, or ATAs. To transfer an NFT on Solana, you are quite literally moving that asset from one ATA to another ATA, rather than just updating an internal list in a single smart contract. And for metadata, EVM often uses optional contract storage, while Solana uses a dedicated Metaplex program-derived address, or PDA. The big takeaway here? Everything on Solana demands that you are thorough, precise, and extremely explicit about where data lives and exactly who owns it. Which brings us to Section 3, the decision workflow, 5 steps before you code. I am giving you fair warning right now. If you don't make these crucial architectural decisions at this exact stage, you are going to face some incredibly painful, migraine-inducing refactoring when you actually start writing your minting and transfer code. So measure twice, cut once. Think of this 5-step workflow as your ultimate blueprint checklist. The answers here dictate your instruction sets, your account passing, and your signature checks. We're looking at mutability policy, authority topology, transfer semantics, your ATA strategy, and metadata provenance. Let's break them down one by one. Step 1 is your mutability policy. The really interesting aspect here is the finality of it. You have to decide, are you going to seal your metadata for immutable provenance or retain an authority to make edits later? If you're launching a high-value art NFT collection, immutable provenance is usually the standard. You mint it, and then you set the authority to null. Bam, it's locked forever. But say you're building a gaming asset where the token stats might level up over time. In that case, you absolutely must deliberately design your program to retain a designated metadata authority. Step 2 is authority topology. So the crucial point is right here. How do you actually plan to upgrade in the future? Your choice completely determines how you roll out future token behavior updates. Do you want program-level upgradability? This means you can update the shared program binary, which instantly affects all mints relying on it. But keep in mind, this is highly centralized and usually requires a strict multi-sig or governance structure, so people actually trust it. Or do you want per-mint authority, where you have a stable PDA controlling each individual mint? This gives you granular control, but it definitely changes how you manage your keys across a massive collection. Step 3 is transfer semantics, specifically looking at the delegate pattern. Let's be honest, EVM allowance mappings can be a bit chaotic. You approve a marketplace to spend an infinite amount of your tokens, and that permission just sits there silently in the contract storage forever. Solana does not play that game. Solana requires absolute explicitness. If a marketplace is going to move a token on your behalf, you must use the strict delegate pattern. This requires explicit authority signatures and utilizing the token program's specific delegate instructions. It's incredibly secure, but you have to actively build that signature orchestration right into your transaction flow. Step 4 is your ATA strategy, and this one is purely a user experience versus cost trade-off. Are you going to use proactive creation or on-demand creation for your associated token accounts? If you create them proactively, say during wallet onboarding, you're paying higher upfront network fees. But later, when the user trades or receives a token, there is zero friction. It just works. If you choose on-demand creation, your initial costs are super low, but the very first time a user interacts with that token, the transaction is way more complex because it literally has to spawn in the ATA on the fly. You just have to decide what your users will actually tolerate. The final step, step 5, is metadata provenance. You have to standardize your URI conventions and hashing schemes. Because Solana separates the token ownership from the descriptive data, what you decide to store on-chain directly dictates how the Metaplex program is going to verify things like collection badges and automated royalties. If your off-chain storage pointers are sloppy, indexers and verification services simply will not trust your content. It's as simple as that.
All right, Section 4, finalizing blueprints. Let's summarize.
Let's bring everyone back to the drafting table for a quick, punchy recap. We've gone through the shift in thinking, we mapped the mechanics, and walked through the 5 crucial decisions. Please remember, these aren't just abstract computer science concepts. These are literal levers you are going to set in your code. First, always separate the program binaries from the state accounts in your mind. Second, decide your mutability and authority topology early. Are you going to lock it down or keep it upgradable? Third, translate those old implicit EVM allowances into Solana's explicit delegate instructions. And fourth, lock in an ATA creation strategy that perfectly balances your application's user experience with network costs. So the ultimate question remains. Are you ready to map your decisions to concrete associated token accounts? Because that is exactly where we go next. I highly encourage you to take these blueprints, review your specific project's requirements, and visit Forge College to dive deeper into this subject and explore a ton of other incredible Web3 topics. You've got the foundation now. It's time to start building. Thanks for joining me on this explainer brought to you by Forge College. I'll see you in the next one.